Now we come to chapter 2, electrostatic potential and capacitance. And capacitance kanaga lai capacitor nangak lai akoi daina class 10 the resistance na lakdu resistor nangak lai bidagi adumaina lakturini potentials haibisidi taramani potential gi idea sini ngasi tanadosi karma makal potential no har matam da leng na charge na puthor electrostatic web capacitance se hypetang yengamu capacitor ganaga leibisi sida lady ma'am se capacitor ngakani makan koi radio bu thugai ni khang de tv kai ni khang de dum ba yeng matam da smaina tawba khara dum thengna ni noina or simply smai roundang ga ta ba makan mayam leibani smaina yungaga leiba kangu zu leibani makan suma mayam de na koina capacitor na haise sig maramda kona torkani khoi hojik oina di sigiri yengsigo akoi conservative force abi ideas ma juning jang matare spring force gravitational force में हमसे conservative force नहीं है कोई न था न तमक पदा वाला conservative force है तार दी they are forces which depends on initial position and final position only मान set पर पाते दा depend दौग दब initial का final का तंग दा depend दौगी बा then non conservative काना कसु लेगेनी frictional force है का कसु अदुना तौरा का न येंगसी तौरदी Coulomb force between two stationary charges like gravitational force is also a conservative force. Coulomb force conservative nehare. This is not surprising since both have inverse square dependence on a distance and differ mainly in a proportionality constant. The masses in gravitational law and replaced by charges in Coulomb's law. Haidi koi nojikta tamakivida F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square and tamakivni for Coulomb gravitational force kidana kamain tamaki akoina G m1 m2 divided by R square and asi ahambagi constants the can I have ni instead of charges in the mass me amoirpa R inverse square law animakta follow the winners high. Thus, like a potential energy of a mass in gravitational field, we define electrostatic potential energy of a charge in an electrostatic field. Kamaina define the rino habdu makhada yengaksi and agyantani. Consider an electrostatic field due to some charge configuration. For simplicity, consider the electric field E vector due to charge Q placed at the origin. Imagine we bring a test charge small q from R to P against the repulsive force on it due to charge. The high demand is the charge Q have a malade Q one as over. Then there is the command of the charge macha pusale Q macha bot manava charge either positive ngak to oibni khangde negative ngak to oibni khangde pusale enghalase moise manata argadi kaidawe hai moi manata argadi repel tawna doini and therefore si taw matamda moise repel tawni from R haiba point sidagi P haiba point sitana porku matamda this charge will experience some repulsive force kara experience it only the adugi force to ni F ex the external force and EDC or aduni si is the EDC kamain tawgeni yengsi this charge greater than 0 of the positive oil have ni lejare sigi huziki point R sidagi P sibu porak pada thabak kharedi tawngani by this test charge sina test charge ni sina source charge ni pusargang matamje thabak kara tawngani tawriba thabak tu buni akoina stage da define tawise work done by external forces in moving charge q small q from r to p r dagi p tana porko matam da choba thabak to f dot dr, and this is the work done equal to f dot dr na integration of sigisida koi tamgrabani class 11 da that force into displacement gives work done sigisna calculus form the ibagi wa khaktani dot product lawramnina scalar product ni this work done is a scalar do lakani sumaina leijare leiraba matung sida kamain tawre mathakta haipitang iramisiong we apply external force just enough to counter the repulsive electric force sigi repulsive electric force di inthorak to ni mangonda mana changiba direction du da aduna hejida lowre to negative sign there is no net force on or acceleration of the charge when it is brought from r to p it is brought with infinitesimally slow constant speed yamna tappa infinitesimally small dr distance sida yam tapna yamna pick na tena porakpani ko adudai kamain tawga matamda integrate taw taragadi mayam am phangdoini there should be no acceleration gaika leiba kemya de hojiki se sigi se ibasi sumain irasu yar electric force lom da minus negative yarga this work done is against electrostatic repulsive force and gets stored as potential energy amana amagi opposite oinari se work done je charge som da pusalapani work done is against magi field gi against oidoinia positive mark oina bina ingaina doinia aduna ni negative mi hoise at every point in electric field a particle with charge q possesses a certain electrostatic potential energy this work done increases its potential energy by an amount equal to potential energy difference between r and p hojiki pusalako matam sida sida karambadano r leibse sida r leire sida p leire sida q achoba minus q je somna kan pusale si pusalako matam sida r gi mapa sida su potential energy ma leramgani known as akoina koksala ur ko wama p gi mapa da su leramgani up ko wama moi ani gi si ani gi difference sibu kai hai am tamda potential energy difference and high aduni se sida irami se del u is equal to up minus ur si ani se gi difference bu ne akoina work done na tawgrido in bringing charge r dagi p dana porakbada changba or tawgiba work done do aduni potential energy difference this is equal to this work done makha tarak point yengu we can define the VRA electric potential energy difference between 2 points as work required to be done by an external force in moving charge q from one point to another for electric field of an arbitrary charge configuration electric potential difference ay taragadi kai haire work done in bringing a charge from one point to the other charge am lerame man electric field pitho leram doni sigi again sida tel charge am porakpada mafam am dagi mafam da porakpa to thabuk to adubu electric potential difference ibr name say sida important comments and hide yengsengo the right side of equation 2.2 where is 2.2 say later sige se depends only on the initial and final positions of the charge r gi mapadara p gi mapadara mana depend tawdoi se sige point ani se katung ne project mamang da haigib du maina mamang du jikta sigi horpada I give the conservative force id magi initial ga final position ga khakta da depend to win I give the adumine depend tawre and therefore coin high adu say this quantity say conservative force then higher money the fundamental characteristic of conservative force kana ga mitu The concept of potential energy would not be meaningful if the work depended on the work. Similarly, conservative nena haibani ahambagi points in magi main idea si next na kai haire defines potential energy difference in terms of physically meaningful quantity known as work. In terms of work, then I was defined the rhythm. Equation 2.2 I give the u del u equal to r minus p. Throwing give the p minus r rp have man p minus r smiley give the. In terms of work to define the within a potential energy difference. Clearly, potential energy so defined is undetermined to within an additive constant. What this means is that the actual value of potential energy is not physically significant. Magi value magi value ado yamna significant way natte siniman haise karigino yengsi. It is only the difference of potential energy that is significance. Magi difference in terms of work the high be yariba quantities is in significant way haise. We can always add an arbitrary constant alpha to the potential energy to every point, since this will not change the potential energy difference. Alpha is a potential energy difference, they will always be the same. Alpha can be any number. The energy potential energy difference. Put it differently, there is a freedom in choosing the point where potential energy is 0. A convenient choice is to have electrostatic potential energy at 0 at infinity. Electrostatic potential energy is infinity, the 0 order. The combine lakpa yai have the r dagi p book pusalapana queen tokimni r dagi p book ana sigisi. Instead of r when infinity the level infinity p book pusaladi combine tawni have the yang. Then this becomes 0 tagre lem how is a work done is up katangai hore at this point. Since the point p is arbitrary, equations in a provides us with a definition of potential energy of a charge q at any point. Definition potential energy of a charge q at a point in the presence of field due to any charge is the work done by external force in bringing the charge q from infinity to that point. Among the defined the potential difference, the electrostatic potential difference ni, which is the work done in bringing from one point to the other. Difference ki potential energy high targadi kaino high matam the potential energy at a point high targadi. It is the work done in bringing a charge infinity dagi uski point of the pork but that changba towa work done do adubune high dus. Sina potential energy infinity dagi usi point pork matam. Next na koi electrostatic potential I was yengsi.